Let's practice graphing some quadratic functions that are written in vertex form together. Now before we get started, it's important to know what vertex form is. So we have f of x is equal to, we have this value of a, which is going to be a number in front, multiplied by the quantity of x minus h squared, and then we're going to add k on afterwards, right? Now this x and f of x are really just x and y coordinates on this function. Now what about the a, h, and k? Well, a is going to let us know if this graph is going to be narrower or wider. We also call that a vertical stretch or shrink. So the graph is going to get kind of skinnier or wider, narrower or wider. And then the value of h here is going to tell us if we are shifting the graph left or right at all. That's going to affect the AOS, or axis of symmetry. And then we have this value of k, which is going to let us know if we're shifting this graph up or down at all. And that's also going to affect where the vertex is going to be. So now that we know vertex form, we reviewed it just a little bit, let's look at number 1, where we have f of x is equal to the quantity of x plus 2 squared minus 1. And let's go ahead and write down what our a, h, and k are equal to. So there's an invisible 1 in front by the identity property of multiplication. So we're going to write x plus 2 squared and then minus 1. So this 1 in front here is going to let us know that a is equal to 1. If a is equal to 1, that means we're going to have no reflections as well as no vertical stretches or shrinks. Next, we have this plus 2 in here, and that actually lets us know that h is going to be negative 2, since the formula has a negative in it. So if it says a plus sign, we must be subtracting 2 negatives to get a plus 2. We have this negative 1 at the end here, which lets us know that this graph is going to be moving up and down a little bit, and that's going to be k is equal to negative 1. Unlike standard form, graphing from vertex form is much more convenient. We know h is equal to negative 2, so that's actually going to be our AOS. So that means that x is going to equal negative 2. I'm going to go ahead and put negative 2 in right over here, but the AOS, or axis of symmetry, is going to be x equals that negative 2. That's the AOS right over here. And what's also convenient about having vertex form is that the y value we already know for the vertex, and that's going to be negative 1. So this is where the vertex is going to be located. It's going to be at this point of negative 2 comma negative 1. Now before we keep going, let's just go ahead and put this on an xy plane to get started. We know that our axis of symmetry is going to be at that vertical line of x equals negative 2. So I'm just going to go ahead and start by writing in that vertical line, which is going to be our AOS, or the center of the parabola. Next, we know the vertex is at this ordered pair of negative 2 comma negative 1. So let's go ahead and see where that's going to be. So here's negative 1. And if we plot that point, if we go negative 2 to the left and down 1, then I think our vertex is going to be over here in quadrant 3. So there we have the foundation of this graph a little bit here. We have the vertex, that's done. We have the AOS, that's also done. Let's see if we can finish graphing this using a few more points. At this point, we just have to create some values that are a little bit bigger and a little bit smaller from our x value of negative 2. Now something I'm going to choose to do here is move the same distance away. So let's go a little bit smaller from negative 2. Maybe we can choose something like negative 3. And if we go 1 smaller, then we're going to go 1 bigger on this side as well. But again, if we plug in negative 1 into the function or negative 3, they should get us the same y values, or f of x values, coming out. After that, we're going to choose 2 more numbers here. And if we do that, I'm going to go ahead and choose 0, that's a little bit bigger, and then negative 4, which is 1 smaller, 1 bigger in each direction. So between negative 1 and negative 3, you get to choose, but let's go ahead and plug it into the function. So I'm going to choose negative 1. So if I do that, I'm going to say, what is f of negative 1? So we're going to plug in negative 1 into the function. If we do that, it's going to be negative 1 plus 2 squared minus 1. That's going to end up being positive 1 squared minus 1. 1 squared is going to be 1. 1 minus 1 is equal to 0. So when x is equal to negative 1, then f of x, or f of that negative 1, is equal to 0. So we can go ahead and plug in a 0 and a 0 for both of these locations. So then plotting this negative 3 comma 0, that's going to be along the x-axis over here. And then this negative 1 comma 0 is also going to be along the x-axis, but a little bit to the right. So it should be symmetrical. Okay. Next, we're going to either plug in 0 or negative 4. Each time they're going to get us the same y value, so your choice. I'm going to go with plugging in 0 into this function of f of 0. So let's go ahead and do that. I have some space down here. So I'm going to say f of 0 is going to be 0 plus 2. That's going to be squared and then minus 1. 0 plus 2 is going to be 2. So we have 2 squared minus 1. 2 squared is 4. 4 minus 1 is going to be 3. So when x is 0, y is going to be 3. And so we can plug that in both of these locations. Okay, so plotting this 0, 3, that's going to be along the y-axis right around here. And then plotting this -4, 3, that's going to be just across from that AOS, but on the left side of it instead. Should be symmetrical. Connecting these points in as smooth of a curve as we can. Would be what the graph would look like. We hopefully have everything that we need, including the vertex, which is -2, -1, just making that a little bit more clear here. So we have the vertex, we have the AOS, we also filled in the table, and then we graphed it over here as well. Alrighty, here is number 2. For number 2, we have another function here. Let's go ahead and rewrite this so we have our a value in here as well, because we can't see it. So there's an invisible 1 in front, that's a, and we have this -3, and then squared, and then we have a +2 at the end. Alright, so this 1 over here tells us that a is going to equal +1, so no reflections and no vertical stretches or shrinks. We have this 3 here, or this -3 rather, which means that h is going to equal +3, because we're supposed to have a minus in there, right? Now because h is equal to 3, that means that 3 is going to be where AOS is, so that means x equals 3. That's going to be our AOS, or axis of symmetry. This 2 at the end lets us know that k's value is equal to +2. So because h was equal to +3, that lets us know what the AOS is, as well as the x coordinate of the vertex. And because k is equal to +2, that lets us know what the y coordinate is going to be for our vertex. So I'm going to put our vertex in right over here, just labeling it so it's super clear. And that ordered pair for the vertex is going to be 3, 2. So it's going to be over in quadrant 1. Now let's go ahead and put this on a coordinate plane. We know that our AOS, or axis of symmetry, is this vertical line at x equals +3. So that would be this vertical line right over here. That's an imaginary line that cuts the graph in half. And then we know that the y value here for the vertex is going to be 2. So if we go to the point 3, +2, that's going to be up here in quadrant 1, and this is going to be where the vertex is located. So we know everything is centered around 3, so let's just go pick a number that's smaller than 3. Maybe I'll choose something like that's a little smaller, maybe something like 2. That's going to be 1 smaller, so if we should go 1 bigger, that's going to be 4. And then maybe we can go 2 smaller, just so we can get 0 here, and we can go 2 bigger, and that would be 6. So I like the idea of plugging in 0, because that's a nice one, but feel free to use 1 and 5 if you want as well. Okay. Choose whether you want to use this 2 or 4 right now. They should get you the same y value. I'm going to go ahead and use the 4 because I want to avoid negative numbers here. So if we do f of 4, we plug that in, that's going to be 4 minus 3 squared plus 2. 4 minus 3 is going to be 1, so we have 1 squared plus 2. 1 squared is 1, 1 plus 2 is 3. So when 4 goes in, 3 comes out. So that means when 2 goes in, 3 comes out as well. Plotting these on the graph, we have 2, 3 over here, and we have 4, 3, which is just about to the right over here. Next, we can either plug in 6 or 0. Either one is fine. I'm going to go ahead and plug in 0 here. Totally your choice if you want to try 6 instead. So f of 0 is just going to be 0 minus 3 squared plus 2. 0 minus 3 is going to be negative 3, so we have negative 3 squared plus 2. Negative 3 squared is going to be 9. 9 plus 2 is going to be 11. So when x is 6 or x is 0, both cases we're going to get y values of positive 11. Now, I didn't make my graph big enough to accommodate that 11, so hopefully you can understand that that would be where it would intersect the y-axis. That would be a y-intercept, but I hope you get the idea of what the graph would look like. So we have filled in our table over here. We have a vertex, we have AOS, and we do have a graph with at least 3 points on there. Here's number 3. For number 3, we have this f of x, and then we have this equal to 2 multiplied by x minus 4 squared plus 1. Okay, so let's take a look at each of the pieces here. This 2 in front means that a is going to be equal to 2. It's positive, so it's not going to be reflected at all, but it is going to be a little bit more narrow than usual. So that's called a vertical stretch, so it should look a little bit skinnier than usual. Then we have this 4 located here, and it's a minus 4, so that means h is going to be positive 4, which also means that that's going to be our AOS. So I'm going to go ahead and just write that as our AOS. And hopefully we know that means that it's going to be x is equal to 4 for that AOS. And then finally we have this 1 at the end here, so that means that k is going to equal positive 1. And so that's actually going to be the y coordinate for the vertex here. So I'm going to go ahead and label that in. That's going to be where the vertex is located. And specifically the coordinates are going to be 4, 1. Let's go ahead and take a look at this on a coordinate plane. Now we know that our AOS is going to be at x equals positive 4. So this right here, this vertical line would be our AOS, or axis of symmetry. And then what about for plotting our vertex of 4, 1? Well, we know where 4 is already. Let's go ahead and plot where 1 is going to be. So 4, 1, our vertex is going to be right over here in quadrant 1. Now to fill in the rest of our table, let's just go ahead and choose one number that's higher and one number that's lower. Like let's choose this 3 here, and then we can choose maybe a number that is going to be a little bit easier to use as well. So maybe let's choose 0, which is going to be 3 smaller, so we should go 3 bigger on this side, so that's going to be 8. Okay, let's go ahead and choose between 5 and 3. I'm going to go with using 5, so we can keep with the positives. Let's go ahead and do that. Let's find out what is f of 5. If we do that, that's going to be 2 times the quantity of 5 minus 4. That's going to be squared plus 1. That's going to be 2 times 1 squared plus 1. 1 squared is going to be 1 times 2 is 2. 2 plus 1 is going to equal 3. So it's going to be 5, 3 and 3, 3. 5, 3 is going to be located just about here to the right, and then 3, 3 is going to be right over here to the left. Now for when x is 0 and x is 8, let's just go ahead and use 0 here. That's my preference, so feel free to do something different. I'm going to do f of 0. That's going to be 2 multiplied by 0 minus 4 squared plus 1. 0 minus 4 is going to be negative 4, so it's going to be 2 times negative 4 squared plus 1. Negative 4 squared is 16. 16 times 2 is 32. 32 plus 1 is 33. All right, so my graph is definitely not big enough to accommodate that, but that's going to be our y-intercept, 0, 33, but it's also going to be 8, 33. I'm not going to go ahead and plot that one, but I think we can just fill in the table this way, and then let's go ahead and make our graph. All right, so just a rough sketch here, but this would be what our parabola would look like, and it's a little bit more narrow than usual just because we had an a value of positive 2, so it's going to make that all the y values 2 times higher. Here is number 4. For number 4, we have this f of x, and that's going to be equal to, it says a negative in front, which really means it's negative 1, right? Multiplied by this quantity of x plus 3 squared, and then minus 2. This negative 1 in front lets us know that a is going to equal negative 1. That's going to actually flip the entire graph upside down, so it's going to open down instead of opening up. But there's going to be no stretch or shrink because 1 is just 1, so that's going to be staying the same in terms of the stretching and shrinking. Then we have this plus 3, which lets us know that actually h is equal to negative 3. Okay, so that's going to tell us our AOS. So I'm going to go ahead and write that. Our AOS is going to be x equals that negative 3. And because of this minus 2 at the end here, we know that k is going to equal negative 2. So I'm going to go ahead and write that in, and that's going to be our vertex, this in the middle of the table. And so we can go ahead and say this is going to be negative 3, negative 2 for our vertex, which is located in quadrant 3. So let's go ahead and put this on a coordinate plane. Now we know that our AOS is going to be h equals negative 3, or x is equal to this negative 3. So this right here is going to be our AOS, and this point of negative 3, negative 2 lets us know that our vertex is going to be plotted over here in quadrant 3 at negative 3, negative 2. All right, next up, let's go ahead and just choose some values that are smaller and bigger than negative 3. So smaller than negative 3, let's go with maybe negative 4 here. And then if we went one smaller, we should go one bigger and choose negative 2. And then maybe we can jump up and choose something that's 2 bigger, which is at 0. So we should go 2 smaller, which would be at negative 6. Okay, between this negative 4 and negative 2, I'm going to go ahead and go with this negative 2 here and substitute that in. So we find f of negative 2. That's going to be the opposite of this negative 2 plus 3. This whole thing is squared minus 2. Negative 2 plus 3 is going to be 1, so we have negative and then 1 squared minus 2. 1 squared is going to be 1, and then we have negative of that, so it's going to be negative 1 minus 2, which is equal to negative 3. So when x is negative 2, y is going to be negative 3, but that also means when x is negative 4, y is also negative 3. Next up, we can choose either negative 6 or 0. I'm going to choose 0 here. I'm going to go ahead and substitute that in. So f of 0, that's going to be negative, and then we have 0 plus 3, that quantity squared, minus 2. And then we're going to have 0 plus 3, that's going to be 3. So we have 3 squared and then minus 2. So we have 3 squared is 9, but it's going to be the opposite of that. So it's negative 9 minus 2, and that's going to equal negative 11. So when x is 0, we have negative 11 for y. So when x is negative 6, y is also negative 11. All right, plotting this -4, -3, and -2, -3, that is going to be located just about here roughly. It's going to be opening downwards because a was negative, so it's going to flip the entire parabola upside down. And I'm not actually going to plot the other points of this -6, 11, and 0, -11, just because I don't have a lot of space here, but hopefully you can imagine that, and if you needed to sketch it, you could. So just a rough sketch here, but this is what the parabola would look like. Here's number 5. All right, so right from the beginning here, we can see that a is going to equal this -1/4. So really what that means is the graph is going to be a vertical shrink, or it's going to be wider than usual. We also have a negative a value, so that's going to flip this whole graph upside down as well. Following that, let's go ahead and use this +2. That means that h is actually equal to -2, and that's going to tell us where our AOS is equal to. So this is going to be our AOS. X is equal to -2. And then finally, this +5 over here lets us know that k is going to be equal to +5. And again, that's just the y value of our vertex. So our vertex is going to be located in the middle of our table as usual. And then this ordered pair for the vertex is -2, +5. All right, so for starters, we know that the AOS is going to be x equals -2, since we had h equal -2. So that's going to be this vertical line right over here. And what about the vertex? As for the vertex, that's going to be this point of -2, 5. So plotting that, it's going to be right up here over in quadrant 2. Okay. At this point, we have almost everything we need. We just need a couple more points. Let's maybe choose something that is going to be a little bit bigger. Let's maybe choose something like, I don't know, let's choose -1. And if we go 1 bigger, we should go 1 smaller. And then maybe we choose 0 here and -4. Okay. Now between -1 and -3, choose one to plug in here. I'm going to go with -1, so I'm going to go ahead and do that work on the side. So if we do f of -1, that's going to be -1/4 multiplied by the quantity of -1 plus 2 squared plus 5. -1 plus 2 is going to be 1, and so 1 squared is still going to be 1, and 1 times -1/4 is just -1/4. Add that to 5, that's really just 5 minus 1/4, so it's going to be 4 3/4. Okay, so when x is -1, we're going to get +4 3/4. So when x is -3, we also are going to get y is equal to 4 3/4. Plotting that on the graph, that's going to be maybe roughly here and also roughly here. So it's going to be a little bit wider than usual, which hopefully makes sense because we're multiplying it by -1/4. So it should be opening down and be a little bit wider than usual. Now, what about when x is equal to 0 or -4? I'm going to go with 0 here. So I'm going to plug that 0 in. So it's going to be f of 0. That's going to be -1/4 multiplied by 0 plus 2. That's going to be squared and then plus 5. 0 plus 2 is 2. 2 squared is going to be 4. So we have -1/4 multiplied by 4. And then we're going to add 5. 1/4 of 4 is just 1. So it's going to be -1 plus 5. And that's going to be equal to +4. So when x is 0, y is 4. So when x is -4, y is also +4. Plotting -4, +4, that looks like it would be somewhere around here. And 0, 4 is going to be somewhere along the y-axis right here. All right, so rough sketch going through each of these 5 points. Our parabola would look something like this, a little wider than usual and flipped upside down because of that -1/4 for the a value. Here's number 6. For number 6, let's see if we can identify each of our pieces here. This negative in front lets us know that a is going to equal -1, so it's going to be flipped upside down, but no stretching or shrinking, same wideness or narrowness. Then we have this -1, which lets us know that h is going to equal +1. So that's going to be right over here, and that's going to help us with our AOS, or axis of symmetry. And finally, this +5 out here lets us know that 5 is going to be our y value for the vertex. So let's go ahead and label our vertexes in the middle of our table as we've been practicing. And the vertex is going to be located at 1, +5. All right, looking at a coordinate plane, our AOS is going to be located at x equals 1, or h equals 1. And that's going to be this vertical line right over here. And our vertex is going to be 1, 5. So we're going to go ahead and plot that right over here. And this whole parabola is going to open downwards. Now, let's go ahead and choose some other x values. Now, going a little bit smaller than 1, let's go with 0. A little bigger, that's going to be 2. A little bit smaller would be -1. A little bit bigger would be +3. So let's go and figure out some more points here. Between 0 and 2, I'm actually going to go with 2 here. So let's go ahead and plug this in. This is going to be f of 2. and that's going to be negative, or the opposite of, let's see, 2 minus 1 squared plus 5. 2 minus 1 is going to be 1, 1 squared is 1, times negative 1, so it's going to be negative 1 plus 5, and that's going to equal positive 4. So when x is 2, we're going to get y is 4, so when x is 0, we're also going to get that y is going to equal 4. Plotting 0, 4 down, that's going to be right along the y-axis, that's the y-intercept. And then for 2, 4, that's just going to be on the opposite side of the AOS, so that's going to be right around here. And then finally, what about when x is negative 1 and 3? Well, I'm going to go with 3 here, just because that's my preference. I'm going to go ahead and plug in here and say that this is going to be f of 3, and that's going to be the opposite of, and let's go with 3 minus 1, and it's going to be squared, and then plus 5. 3 minus 1 is going to be 2, so 2 squared is going to be 4, so that's going to be negative 4 plus 5, and negative 4 plus 5 is equal to positive 1. So when x is 3, y is 1, so when x is negative 1, y is also positive 1. Plotting these points, let's go ahead and see. We have negative 1 over here, so negative 1, 1, that's going to be right around here in quadrant 2. And then over for 3, 1, that's going to be right about here in quadrant 1. Drawing a rough sketch here, this would be what the parabola would look like. Here's number 7. For number 7, we have an a value here that's going to be 1/2. So since it's positive, the parabola is going to open up, but it's going to be a little bit wider than usual because we have a value of less than 1 but greater than 0. This 3 over here indicates that our h value is going to be equal to positive 3. So that's actually going to be our AOS, or axis of symmetry. And finally, this minus 4 lets us know that k is going to equal negative 4, so the vertex is going to shift 4 units down after being shifted 3 units to the right of the origin. So the vertex is going to be located right in the middle here, and then we know that those coordinates are going to be 3, negative 4 for the vertex. All right, so to get started, let's go ahead and plot our AOS, which is going to be x equals 3. And so that's going to be our vertical line right over here. And then our vertex is going to be 3, negative 4. So let's go to 3 and then down to negative 4. And that's going to be over in quadrant 4. So this is going to be roughly where our vertex is going to be. Now it's time to just choose some numbers that are nice and easy to use. So I'm going to start by just choosing something like 2, because that's a little smaller, and then 4, because that's a little bit bigger. And then maybe we can choose something like 1 here. 1 is going to be a little bit smaller again by 1, and 1 bigger. Let's choose maybe something like 5. Okay. Between 2 and 4, I'm going to choose 4 to substitute in. So if we find f of 4, that's going to be 4 is going to go in for x, so it's going to be 1/2 multiplied by 4 minus 3. That's going to be squared, and then minus 4. 4 minus 3 is 1. 1 squared is 1. So that's going to be 1/2 times 1, which is still 1/2, and then minus 4. 1/2 minus 4 is just going to be 4 minus 1/2, but make it negative, so that's negative 3 1/2. So when x is 4, y is going to be negative 3 1/2, and when x is 2, y is also going to be negative 3 1/2. 2, negative 3 1/2 is right about here, and then this 4, negative 3 1/2 would be right about here to the other side of that AOS. Now, what about plugging in 5 versus 1? I'm going to go with 5 to keep things positive inside there. So if we do f of 5, that's going to be 1/2 multiplied by this 5 minus 3, and that's going to be squared minus 4. 5 minus 3 is going to be 2. 2 squared is 4. So we're going to do 1/2 of 4 minus 4. Now 1/2 of 4 is just going to be 2, and then so 2 minus 4 is going to equal negative 2. So when x is 5, y is negative 2. So let's go ahead and put negative 2 in for each of these locations. And so 1, negative 2 is just about here, also in quadrant 4, and then 5, negative 2 is symmetrical on the other side of the AOS, just about here. All right, so drawing a smooth curve through each of these points, this is what roughly our parabola would look like. All right, one final practice problem, number 8 here. Let's see what we can figure out from the beginning for our a and our h and our k. So right from the beginning here, we notice that a is going to equal negative 2. So this is going to be a little bit more narrow than usual, or a vertical stretch, and it's also going to be flipped upside down, as well as this positive 4 or plus 4 means that actually h is going to equal negative 4. So that's going to be where AOS is going to be at x equals negative 4. And then finally, this +1 over here lets us know that k is going to equal +1. So that's going to be letting us know where the y value is for our vertex. So our vertex here is going to be at -4, +1. And so let's see where this is going to be on a coordinate plane. All right, so starting off with our AOS, where we know that x is going to equal -4. That's going to be our AOS, or this vertical line right over here. And then for the vertex, it's going to be at -4, +1. So we can go ahead and plot that down as well. That's actually going to be right on the AOS over in quadrant 2. This whole parabola is going to be opening downwards just because a is -2. And so let's go ahead and choose some other x values here. So maybe we can choose something that's a little bit smaller, like -5, something a little bigger, like -3. And maybe we can also choose something that is a little bit more big, which is going to be 3 bigger, which is going to jump to 0. And that would bring us to -8 for the x value here. So just to fill in the table, but we'll see if we can fit it on the graph here. Okay, so let's go with either -5 or -3, plugging this in. I'm going to go with -3. And so I'm going to say this is going to be f of -3. That's going to be -2 multiplied by the quantity of -3 plus 4. That's going to be squared, and then plus 1. Now, -3 plus 4 is 1. 1 squared is 1. 1 times -2 is still going to be -2. So -2 plus 1 is going to be -1. So when x is -3, y is -1. So when x is -5, y is also -1. Plotting these 2 points on the graph, -5, -1 is going to be somewhere right about here, and -3, -1 is going to be right about here. Okay. Now what about when x is 0 or -8? Well, I'm going to go ahead and use the 0 here. So I'm going to find what is f of 0. That's going to be -2 multiplied by 0 plus 4 squared, then plus 1. 0 plus 4 is going to be 4. 4 squared is 16. So we have -2 multiplied by 16 plus 1. -2 times 16 is -32. So -32 plus 1. That's going to be -31. So I guess I could have chosen numbers not as far away, but algebraically that didn't work out too bad. Just won't be able to graph this on here. So up to you, pros and cons, but at least we have points here that weren't too bad to find. Okay, so just using these 3 points here, let's go ahead and sketch this curve. So just a rough sketch here, but this is what this parabola would look like. It's opening down because a is equal to -2, and it's a little bit more narrow or vertical stretch because this value of a is greater than 1. So there you have 8 different practice problems on graphing quadratic functions written in vertex form, where we went ahead and found the AOS as well as the vertex. Then we filled in a table to get some more values, your choice into what you want to choose for those x values, and then we sketched a parabola which represents the pattern or what the graph looks like for each of these quadratic functions. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.